All right, for number 19, the principal P is borrowed and the loan's future value A is given at time T. Determine the loan's simple interest rate R to the nearest tenth of a percent. Well, first we need to get the future value for simple interest formula, which is on your midterm formula sheet. And that is A equals P onto 1 plus RT. And then we plug in what we know. So $2,593.75 equals $2,500 onto 1 plus the R we don't know. And the only tricky part here is T. It's given to us in months, but T has to be in years. So we're going to have 9 divided by 12 for our T, because it's 9 out of 12 months. So I'm going to rewrite that 9/12 actually as 0.75. So we've got the 2,593 and 75 cents equals 2,500 onto 1 plus 0.75 R. Now to solve for R, I'm going to divide both sides by 2,500. And whenever I do that, I get 1.0375 equals 1 plus 0.75 R. So now we need to subtract 1 from both sides, and we're going to get 0.0375 equals 0.75 R. Divide both sides by 0.75. And when we do that, we're going to get 0.05 equals R. Well, again, this is the decimal version. It's asking for the percent, so we need to know that we're going to take our 0.05 and either move the decimal 2 places to the right, which is the same as multiplying by 100. So 5% would be the interest rate for that one. For 22, for 20, how much money should be deposited today in an account that earns 7.5% compounded monthly so that it will accumulate $11,000 in 3 years? Well, to do that one, we're going to need the formula A equals P onto 1 plus R over N to the NT power. And we know everything except for the P. So now if we plug in all of our values for our compound interest formula, we're going to have $11,000 as the accumulated value. And then equals P onto 1 plus, the rate is 7.5%. Converting that to a decimal, we get 0.075 over N is the number of times it compounds. It says per year, it says compounds monthly, so over 12 to the power of 12 times, and then T is in years, and it says 3 years. So now if we work this out, we can put this together and then raise it to the 36th power, and we will get 1.251446136. For me, since this is the last answer that I have in my calculator, I'm not going to round because we only have one more set to solve for P, which will be divide both sides by that number. So we cancel on the right, so I have 11,000 divided by my answer, and I get 8,789.83, and then the next decimal, or sorry, the next digit is a 0, so it stays 83. So this is the amount of money that needs to be deposited initially to earn $11,000 in 3 years with a 7.5% interest rate compounded monthly. Okay, for number 21, Determine the effective annual yield to the nearest hundredth of a percent for each of the investments, then select the better investment. Well, we need to have the proper formula, which for our effective annual yield is y equals 1 plus r over n to the n minus 1. So for our first option at 6% compounded annually, we'll have y equals 1 plus our 6% over compounded semi-annually is twice per year, squared, because n is the same in both, minus 1. And when we put that in our calculator, we're going to get 0.0609, which is 6.09%. And for our second option, of the 5.9% compounded daily, and we're going to have to change this to 0.059 over 360 to the 360th power minus 1. And when we put that in our calculator, we will get 0.06077, which is 6.08%. For number 22, we need to use the following formula, so the payment formula, to determine the periodic deposit for the scenario given to us in the chart. Well, we're trying to figure out how much money we need to put in every 3 months so that we reach $30,000 in 6 years if our money is being compounded quarterly at 7.5%. So for part A, our payments are going to be, so A is our accumulated value, so $30,000, onto R over N, so 0.075, over quarterly means 4 times per year, and then all of that is over 1 plus, and again the rate 0.075 over n, which is still 4, to the power of 4 times. We want to do it in 6 years, so our t is 6 minus 1. And if you put all of that in your calculator, you'll get 1001.26. And our directions say then round up to the nearest dollar. So we'll get $1,002. And then for B, how much of the financial goal comes from deposits and how much from interest? Well, to figure that out, we know that we're making payments of $1,002. And we're making them every 3 months, or 4 times per year. And we're doing this for 6 years. So if we multiply all that together, we get $24,048. So this is the amount of money we actually invested, which means to figure out the interest, then we have to take the $30,000 we accumulated and subtract the $24,048, and we get $5,952. Came from interest. For number 23, the price of a small cabin is $65,000. The bank requires a 5% down payment. The buyer is offered 2 mortgage options, 20-year fixed at 8.5% and 30-year fixed at 8.5%. Calculate the amount of interest paid for each option. How much does the buyer save in interest with a 20-year option? Well, the first thing we have to do is figure out how much the loan actually is. If we're putting 5% down, then we're taking a loan out on 95% of the value of the house. So if we do 95%, or 0.95, times the cost of the house, so the $65,000, we'll find out we're borrowing $61,750. Once we know the amount that we're borrowing, or our principal, then we need to use our payment formula, or the loan payment formula for fixed installment loans. And if you look on your formula sheet, payment equals P times R over N all over 1 minus 1 plus r over n to the negative nt. So we're just going to use this formula and plug in for each scenario. So for our first scenario, with the 20-year loan and 8.5%, the principal of $61,750 times that 8.5% over, and this is a mortgage, so we're talking about 12 times per year, or monthly payments, over 1 minus 1 plus our 0.085, again, over 12, to the power of negative 12 times, and this is a 20-year loan, so our t is 20. And when we put that in our calculator, we're going to get $535.83, but it says round to the nearest dollar as needed. So for our answer, this will be $536. For our second scenario, where we have a 30-year loan, we're going to use our same formula. So we start out with the same interest of $61,750, the same interest rate of 8.5%, still monthly payments, all over 1 minus 1 plus 0.085 over 12, and the only thing that actually changes, instead of having a 20 for our t, we're going to have 30. And when we calculate that, we're going to get $474.80, rounding to the nearest dollar. That will be $475. And then it wants us to find out, well, how much are we going to save? To find out how much we're going to save, we need to figure out how much each of these loans will cost us over the life of the loan. For scenario 1, we're paying $536 every month, so 12 months per year for 20 years. And this gives us that we're going to be paying $128,640. However, we also need to take out the price of the loan because we're just trying to find the interest. So minus $61,750, and that'll give us $66,890 in interest with scenario 1. For scenario 2, we're going to do a similar idea. So $475, we're making monthly payments, so 12 times per year, for 30 years. And whenever we multiply that, we're going to get $171,000. Again, this is total that we've paid in. We need to subtract out the amount we actually borrowed to figure out the interest we paid, which is going to be $109,250. So the difference between these two numbers is how much we would save by using the 20-year mortgage instead of the 30-year mortgage option. Whenever we subtract, we get that we will save $42,360. Okay, let's look at number 24. So 24 gives us a credit card bill, essentially, and we need to go through and first find the average daily balance. Well, to do that, I find it useful to add two columns. So let's look at the number of days for each balance and the actual balance on those days. So we started with $6,230, and our billing date is on March 1st. So our first balance is $6,230, and we have that balance from the 1st through the 4th, because on the 5th it changes. So for days 1, 2, 3, and 4. So that'll be 4 days. Well, then on the 5th day, we make a payment of $400. It's a credit. So that reduces our balance to $5,830. And that stays the same balance for the 5th and the 6th, so for 2 days. And then we go to a restaurant and charge $30, so our balance goes to $5,860, and it stays that balance on the 7th, 8th, 9th, 10th, and 11th, which will be 5 days. On the 12th, we charge groceries. So we charge $70, which brings our balance up to $5,930. And it stays that balance for the 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, and 20th. So for 9 days. And then we have car repairs, which are $240. That $240 brings our balance up to $6,170. And it stays that way from the 21st through the 31st. So on the 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, and 30th and 31st. So 11 days. And the reason for counting those days out loud is because a lot of times students will subtract numbers and they're not including either the beginning or the ending date. So 21 to 31 is 11 days because we include both the 21st and the 31st. To figure out our average balance now, we're going to take 4 times 6,230 and then plus 2 times 5,830 plus 5 times 5,860 plus 9 times 5,930 plus 11 times 6,170, and that totals up to $187,120. However, this needs to be divided by the 31 days. If we divide that, we're going to get 6,036.129, which means 6,036.13 whenever we round to the nearest penny. So the average daily balance for the billing period is going to be $6,036.13. And then we need to find the interest to be paid. Well, we know that we have an interest rate of 1.5%, and that's our monthly interest rate. So we can just go ahead and multiply. So our 1.5%, so 0.015, times that $6,036.13 is going to give us $90.54. So that'll be the interest we need to pay. And then we need to find the balance due on April 1st. Now this is a little tricky because most students, or many students, want to add this $6,036 plus $90. However, to find the balance due, we need our ending balance, which we worked out up here, and our ending balance was $6,170. And we have to add the interest, so $90.54. And now we add those, we get $6,260.54. And then for the last part, it says that the credit card company requires a $10 minimum monthly payment if the balance owed is less than $360. Otherwise, 1/36 of the balance due. So this is obviously well over $360, so we're going to do 1/36 of the $6,260.54. And whenever we do that, we're going to get $173.90. Following directions, it says round up to the nearest dollar. So our answer will be $174.